2 notes. So what we're going to do now is we are going to look at what's called function arithmetic. And the nice thing is, when you add two functions, we have this notation, and I want you to be comfortable with either. So go ahead and highlight here. If I see f plus g of x, that really is the way that we're going to take f of x plus g of x. If I have f minus g of x, you're going to do f of x minus g of x. If I see f times g of x, that is the equivalent way to say f of x times g of x. And the last one, if I do f divided by g of x, that is simply the way that we say f of x divided by g of x. Okay? So let's look at example 1. If f of x is 2x plus 1 and g of x is x minus 3, we want to find the new function and evaluate the following. So if I have f minus g of 5, let me rewrite this for you. This just means f of 5 minus g of 5. I believe you did function notation in Algebra 1, correct? Is this coming back to you, the f of x, a little bit? So f of 5 means I go to the f function and I replace x with a 5. So that's 2 times 5 plus 1. When you subtract, you have to put a big grouping symbol and subtract whatever comes out. And this might be the hardest thing for us to keep straight. Again, when you subtract g of 5, you have to subtract everything that comes out of g of 5. So that's going to be 5 minus 3, because I'm going to the g function and I'm replacing x with a 5. That's where the 5 minus 3 came from. So this is 10 plus 1 minus 2. So that is 9. Can you see the g of x? It says x minus 3. So g of 5 then is 5 minus 3. G of 5 just means replace the x with the 5. Okay? All right, so now letter B. This is f of negative 1 times g of negative 1. So let's do a big grouping, and that's going to be 2 times negative 1 plus 1, and then that's negative 1 minus 3. So the f function, so let me make sure you're following me here. Okay, when I want f of negative 1, I go to f of x. You see this is f of x is 2x plus 1. You're replacing the x with the negative 1. So that's 2 times negative 1 plus 1. Then g of negative 1 means negative 1 minus 3. Now I have to tidy up those two expressions. So that's negative 2 plus 1 times negative 4. That's negative 1 times negative 4, which is positive 4. Let's look at letter C, f divided by g of 5. So this is just the way that we say f of 5 divided by g of 5. Well, f of 5 is 2 times 5 plus 1. G of 5 is 5 minus 3. So I get 11 over 2, final answer. Yeah, Becca. Yes, you can. Yeah, absolutely you can. But remember, PEMDAS, or please excuse my dear Aunt Sally, when they're numbers, typically we do inside the parenthesis first before you FOIL, but there was nothing wrong with FOILing, right? Yeah. All right, when looking at real-world data, it is often hard to decide whether or not there is a functional relationship. For example, if you measure the height of every student in your class and the weight of his or her backpack, you may collect a data set in which each student height is paired with only one backpack weight. But does that mean no two students of the same height could have backpacks of different weights? No, it doesn't. Does it mean you shouldn't try to model the situation with a function? Well, we might want to, and if you remember from Algebra 1, you did a line of best fit, so sometimes that would work. So who cares about doing function operations? Well, let's look at example 2 together. The cost of producing X skateboards in a factory is given by C of X equals 28X plus 450. So X is the number of skateboards and C of X is the cost. So C of X is the cost. That's not C times X. It's function notation. C of X is another way to describe the Y value. The revenue of producing X tennis shoes, oh, whoops, wait a minute. This is supposed to be the same thing. So let's call these skateboards because it doesn't make any sense to have two different options there. Sorry, that's a typo. So if the cost of producing X skateboards is 28X plus 450, and the revenue is 100 times X, find the profit. Well, let me make sure we're all on the same page here. When you have a company, revenue is like, say the skateboards are $100. Well, like that's what they sell them for. If they were to sell 5 skateboards, the revenue would be $500. Okay, revenue is how much money did the company bring in. So again, if a skateboard was $100 and they sold 5 skateboards, their revenue was $500. The cost is like labor. How much are they paying their workers per hour? But it's also the materials to make the skateboard. It's also the electricity and lighting of your building that you're working in. So there's a lot of factors that go into the cost. Then profit is equal to the revenue minus the cost. So our revenue was 100x minus, now be careful here, anytime you are subtracting functions, you have to put a parenthesis around the second function because you have to subtract the entire, in this case, cost function. So this is 100x minus 28x minus 450. Combining like terms, that's 72x minus 450. What does this mean? This is the profit of producing X skateboards. All right, example 3. This is just doing, yeah, Davey? Yes, you distribute the minus sign. So, yes. If it were addition, then there wouldn't be any, you would be distributing an addition sign, but that doesn't change anything. All right, example 3, f of x equals x squared minus 9, and g of x equals x plus 3. So if I want f times g of 2, and I went ahead and stated it for you this time. That's f of 2 times g of 2. I'm going to pause a moment and give you a head start. And if you're a fast worker, go on to B, but maybe wait for me for C and D. All right, so here we go. F of 2, that would be 2 squared minus 9, and I'm going to figure out what that is, so I need a parenthesis around it, times g of 2 is 2 plus 3. So that's what? 4 minus 9, which is negative 5 times 5. You should get negative 25. So f over g of negative 1 means f of negative 1 divided by g of negative 1. So be careful when you square a negative. What happens when you square a negative? It becomes positive. So x squared means you're taking the number times itself. So that's going to be positive. So that's 1 minus 9 over 2. That's negative 8 over 2, which is negative 4. All right, now we're going to do f times g of x. So now I don't have any numbers. It's going to stay the function. So watch what happens. This is x squared minus 9 times x plus 3. So I'm going to use FOIL, or what we call the extended distributive property. I'm going to take x squared times x and x squared times 3. So that's x cubed plus 3x squared. Again, I took x squared times the x and x squared times the 3. Then I'm going to take the minus 9 and I'm going to distribute that. And that gives me minus 9x minus 27. Are there any like terms? No, so that's my final answer. All right, letter D. I'm going to get x squared minus 9 over x plus 3. Now I am going to pull back some Algebra 1 for you. If I have x squared minus 9, that's x plus 3 times x minus 3. That does factor as a difference of two squares. We will review factoring this year, so that's not the main point of this section, but I thought it would be good to bring it back. So the top factors into x plus 3 times x minus 3, those cancel. They won't always cancel, but sometimes they do. All right, that finishes the notes. Yeah, Davey? Oh, that's